Hello and welcome to our bushfire mitigation webinar. My name is Nicci Rossouw. I'm the CEO of Robotics Australia Group, and thank you very much for joining us today. Robotics Australia Group is the peak body for robotics in Australia. We currently have over 43 members and we are a not-for-profit organisation. Our main sponsors are Laing O'Rourke, Advanced Navigation, RSM Australia, and Vex Robotics. So thank you very much to our sponsors for their ongoing support, and of course our network members. We couldn't do it without you. I'd really like to thank Dario and Rob Mahony for joining us today. It's a very timely time with the Victorian bushfires raging as we speak. Bushfire mitigation is a very topical topic at the moment in Australia, and probably will be ongoing just because of the climate that we live in. So Rob, I think I'll start with your presentation. If you wouldn't mind doing an introduction, who you are, a bit of your background and history, and we'll go from there.
Thank you very much, Nicci. So it's a pleasure to be here and talk a little bit about the Bushfire Centre of Excellence. So I'm a professor in robotics at the Australian National University. I have done most of my life's work in aerial robotics. I did a lot of the early work on quad rotors, the scientific work that went before the industrial sort of boom in that technology, and now I'm working in a range of areas in the same space. And so as part of that, and in collaboration with Andrew Tridgell from ArduPilot, and we're collaborating with Carbonix and some other partners I'll talk about, we've been working in the Bushfire Centre of Excellence, which is funded by Optus primarily, and ANU. And we've been looking at some of the questions around bushfire mitigation. So I guess I'll just go on with the webinar and talk a little bit about our perspective on this. So just a little bit of background in bushfires. So lightning ignitions are actually responsible for almost all of the area of burnt land in recent fires in Australia. And the reason for this is because when fires start close to built environments, so close on people's properties and on roads, it's actually quite easy to get to the fire quickly with the fire services, and they can often put the fire out. And so when fires start in inaccessible bushland, they can't get to the fire quickly, and they can't put it out, and then it grows. And once fires grow over a certain size in Australia, as we see in Victoria, you essentially can't put them out. So you have to wait until they go out and simply go into a mode of protecting property. So there's actually a really interesting problem there and a paradigm change, because up until 2019 and the really massive fires then, there was actually a principle that was in play, which was that fires in deep bushland, in national parks, were a natural phenomenon. So it wasn't actually a problem if a fire started in deep bushland. It was considered natural, and all you would do is control it when it reached in the built environment. And I think what we're living through now is an understanding that there's, with climate change and with the changing population densities in the world, that sort of approach is no longer viable. And we really have to take a more active management approach to bushland, to fires in deep bushland. And so part of that is the paradigm change that we're really trying to champion at ANU. So I consider this to be a national challenge. I consider it to be a new challenge, and I consider it to be a challenge that can only be solved through new technology. It's a paradigm change from how fires have been fought in the past. Which I should make very clear, I am a big believer in the fire services in Australia. I think they do a fabulous job. And I think in the areas where they have got established technology and have been developing that technology, It is fit for purpose and extremely competent. There's no question about the competence of our fire services. What I'm posing here is a new paradigm that really wasn't tackled until recently. And essentially, the argument on the left there is that if you can actually get to a fire when it's small, it's relatively easy to put out. If you let it grow beyond about 4 or 5 hectares, it becomes almost impossible to put out, especially in catastrophic or extreme conditions. So the challenge I see is to detect and extinguish lightning and other ignitions, but lightning is the main one that happens in deep and inaccessible bushlands before they grow uncontrollable. And so that depends a little bit on the conditions, how long that is, but we're talking minutes, tens of minutes perhaps, through to hours or even days for some cases. And so our vision is that this requires a new suite of technology, and that's why we're engaging with Robotics Australia and with technology companies and working on these. And we are working to champion this. So we're a research organisation. We're the Australian National University. It's not our job to build and sell technology. And so what we're trying to do, our vision statement, is to undertake research and development, which is our fundamental job, to demonstrate technological capabilities where we think that there's a capability that isn't being well provided in the industry. We engage in thought leadership. We advocate for standards and regulations to make that technology Australia-wide rather than local. We're an organisation that companies can come to for independent evaluation and benchmarking. And so you can take evaluation benchmarking we provide and go to government with it. And we're very close to a number of different organisations and parts of the government that are looking. And we're very keen on supporting innovation. So we have an open source IP principle. So all of the work that we do is open source. So anything you see, you can come and ask us, and we'll give you the code, give you the principles and everything, and work with that. So that's what we're trying to do. At the moment, we have 4 areas that I thought I'd talk about today in this forum. So prevention and risk reduction, some lightning forecasting and detection, some ignition detection. Those 3 projects we really have active activities in, and we're also interested in the safe and rapid suppression stuff. So let me run through those quickly, slide by slide. So prevention and risk reduction, the capability that we're trying to demonstrate is a modelling capability. So we're really trying to provide Australia with data that will enable very detailed analysis of fire risk, and as such allow authorities to target the prevention activities they take on, target where they put resources and such like. And so to this end, we've been working very heavily in satellite data and modelling of moisture content of fuels and modelling of flammability. So flammability is much more subtle than moisture content. It has to do with how much undergrowth there is in forested areas, how much canopy, how flammable the undergrowth is, and the litter that's on the forest floor. And so these are very detailed models that, if they're properly developed, they can actually go into these fire models. They can tell us about where fires are likely to occur and also how fires propagate. So in real time, we could hope to propagate information actually at the individual firefighter level about fire behaviour, likely fire progression, and things like that that would make a lot of difference. So I will mention one project that's really important, which is the OzFuel project. And so this would be a low Earth orbit satellite that we've done a lot of preliminary work on. We're about a third of the way through the prototyping preliminary work. We're actually looking for a funding injection, and we're looking for partners to be able to build the first prototype and actually launch that prototype. So if you have any ears that you can talk to and you hear about Ausfuel, make sure you support it. And that would be a prototype of a detailed sensor that would be tuned to eucalyptus frequencies and the information we need for Australia. And it would essentially be low Earth, so it would be swathes of Australia in very high detail, acquiring data over a period of a week or two, and then you get the same data again as the satellite moved its orbit around. And so that would enable us, if we can get that, to go from what we are now, which is tens of meters per pixel, down to meters per pixel. And eventually my dream would be to actually have individual trees identified in the Australian bushland. And that would then enable us, if there's a lightning strike, to be able to say something about which tree it hit. And that sort of information would be incredible. That's daydream at the moment, but very exciting. So a second part of what we're doing is actually the key step, which is every lightning strike that hits the ground, we want to measure, we want to identify where it hits, and we want to build a risk model of ignition for that. So for this work, we've been working with a company called Fire Neural Networks from Florida, and their kit is there on the right. That's one of the 6 units that we've installed around ACT at the moment, and you can see the positions on the left. And what Fire Neural Network does is it receives the electromagnetic wave of the lightning strike, does a triangulation in space and time, and actually maps the 3D lightning strike. So it maps the lightning from the cloud, the actual path it takes, and to where it hits on the ground. And we've been benchmarking their accuracy. At the moment, we're getting around about 150 meters of accuracy out of their system, which is about 10 times better than the reported accuracy out of Weather Zone and other systems. Now, mind you, Weather Zone and other lightning reporting systems are much, much broader. And then what we're hoping to do is work with that technology. And as I say, my dream is to get it down to 10 meters or 5 meters, and then you're actually able to correlate to what tree's been hit. Different trees have different ignition profiles. So if you can actually get to that level, you can say something quite strong about what's actually going on. And this is very much not a human, this has got to be AI, right? So this is lightning strikes from a lightning storm that went through over Canberra in the December period of 2023. And what you see here, lightning strikes occurred during a single storm. So there's thousands of lightning strikes. And we've got 2 lightning strikes which were identified as direct current events. So they're events where a significant amount of current passed, which we can try and identify from the lightning strike technology. And these were the ones that actually caused ignition. And then there were also 3 other lightning strikes identified as direct current events which didn't cause ignition. So this is actually quite a powerful technology if we can actually do it. Nicci, did you want me to check and look at chat questions during the presentation, or will you interrupt? Or
I'm happy for you to finish your presentation, Rob, and then we can address them. But if you feel like there is a question there, but it's not going to interrupt your flow, has there been much engagement with First Nations people and enlisting their knowledge for backburning and fuel load mitigation strategies, etc., from Ian?
Okay, so First Nations, perhaps in the conversation we can bring that one up, because there is a lot to say, but it's orthogonal to the technology that I'm talking about now. So I'm really happy to answer that question, but let's keep going. And so we'll come back to that if you could hang on to it. All right, so the third capability that we've been working on is the validation question. So as you saw in the detection question, we have from this particular storm, we actually outlined 5 potential ignitions, 2 of which were actually ignitions, neither of which turned into fires. So you don't want to be ringing the bell on every ignition. And this is actually a really important aspect. type 2 errors. It cannot be warning you about every potential ignition. It needs to be warning you about those that are actually a problem. Otherwise, you're crying wolf to the RFS, and after a week, they'll turn the system off. So we've got a number of technologies we're working on to try and fill that gap. So we're working at the base level of ground sensors. And so the bottom left photograph here in that set of 4 is one of the technologies that we're working on, which is a CO2 detector. It detects actually a carbon in the atmosphere as well. So it actually detects the underlying chemicals in a fire. And so these would be the sort of sensors that we would be hoping to drop by drone into an environment where there has been ignition at the moment. So what we've got is a concern of what we call a candlestick ignition or something similar. So a candlestick ignition is when you have a hollow tree and the lightning's gone down the inside of the tree and ignited inside the tree. So it's very hard to see, but it will burn through the tree over time, and then it will ignite. The other one that you get sometimes is lightning that goes down the outside of a tree through the root system of a tree and ignites the root system, and that can smolder and then ignite the leaf litter underneath the tree. So that's one. Another one is this technology of camera-based visual analytics. So these top 2 photos in the little collage down the bottom left there is from our camera technology. So we've got a camera where we're seeing a fire, and then we're using standard machine learning techniques to excerpt out the fire and provide a warning. So this is reasonably well-established technologies. A number of companies provide this technology in Australia. We're doing work in the thought leadership level where we're developing these algorithms. They're open source, and we're working very hard to try and build standards in Australia so that we can actually have data exchange. This is a really important technology, but it's also a technology that I think needs to be accessible in a very broad way. So that's the program that we're working on there. Then there's a third technology we're working on with Carbonix. And again, I'll go really quickly because I'm sure Dario will talk through the capabilities of the Carbonix planes, which we're working with, which are fantastic. And the goal of those for us is to be able to get eyes on a potential fire ignition in deep bushland as quickly as possible. So our concept here is a storm chaser. You know that there's a dry lightning storm coming through. Carbonix planes are up and flying. Following the storm in the next 5 or 10 minutes, you're able to identify where the lightning is from your lightning detection and then fly the Carbonix plane across, get thermal imagery, RGB imagery very early on. And if there is a very quick ignition, you know about it straight away. And so then you can go into your secondary sort of phases. And if there's a concern that there's ignition, you can drop the ground sensors. And so that's the concept of what we're doing. I mentioned the wildfire sat mission, the Ausfuel, so I'll leave that one out, and the evaluation of fire detection. So we're providing we're partnering with a group called FireTech, which is out of Noosa and is government funded by the Noosa Council. And so they have an environment there where they can prototype and demonstrate actual physical technology. We partner with them to provide a scientific sort of evaluation of new technology. And so if you have a technology that you want to sell to government, come and talk to us. You can demonstrate it. FireTech will write you a report. Tell us about the science. We'll write you a report, and then you can use that to convince government that you've got cutting-edge technology that's accessible and is useful. So that's the service that we're providing there. So I'll finish up and just mention the groups that we're working with. So some of the companies I've talked about are there, but we're working with a wide range of different organisations and companies. And I'll finish up with a picture of a drone that I've come to love and work with, and take any questions or pass back to Nicci for what you want to go to now. Thank you very much.
Rob, thank you very much for your very insightful presentation. Would you like to address Ian's question? Has there been much engagement with First Nations people enlisting their knowledge for backburning and fuel load mitigation strategies?
Absolutely. So it's a really important question, and I'm very very engaged in it. The reality is that managing the environment is one thing, dealing with catastrophic bushfire ignition is another. And so, in a sense, the technological work that we're doing at the moment needs to go into a sort of a separate category. And of course, we talk to First Nations about this, but once there's catastrophic bushfires being ignited in terrible conditions, you really need to just go in and try and figure out how to put them out. There is a separate question there, which is how do you actually manage environments? And one of the key things there is engaging with First Nations in the correct way. So the First Nations people is an oral tradition, and engaging with First Nations people has to be done over long periods of time. It has to involve trust building, and it has to involve programs of management. So that understanding actually has taken a lot of time to be recognised within academia. I think it is recognised now, and there are groups in academia now that are working on building trust and building ongoing programs with First Nations. And as we learn more about how First Nations manage environments, then that knowledge can be brought across into the more Western approach, or the Western knowledge base. So that the problem here is we have a total disconnect with the way we write our knowledge in books and in documents, and the way First Nations teach knowledge in terms of talking to people, and then layers of information that contain cultural. I mean, the First Nations knowledge is embedded in their culture. It's embedded in their trust of who they're talking to. There's a process whereby you can actually access that knowledge, and where you can build trust and then transfer that knowledge into the way we're managing the environment. And so I'm a very strong supporter of that, but I'm not actually actively, and this project is not actually actively working on that, although we're very closely linked to groups in ANU that are. I hope that answers the question. I'm happy to elaborate if necessary.
Ian, if you'd like to, if that's answered your question, if not, please just put another comment in there. Rob, I'd actually like to ask you, I lived in Sassafras, which is in Mount Dandenong. It's probably one of the highest fire danger areas in the world that you could possibly have. I only found it out after we bought the house, and the siren went off, and I phoned my husband and I said, I've got no idea what's going on here. The siren went off, and I rushed out, and he said, well, go and look what the neighbors are doing. I rushed out, no one was doing anything. And I went, well, it can't be that bad. But of course, I lived on Mount Dandenong for 15 years. And I remember every summer, come September, I'd get this very anxious feeling about how wet was the winter. Is our property ready for fire? Have we cleaned? Because it's a responsibility of all homeowners up there to be looking after their properties and things. I did eventually find out that if the siren goes off for 1 minute, it's just a car accident. Not that it's just a car accident, but 5 minutes, you cooked. Like you've left it too long. Like, don't even worry about it. You better stay there and defend your property. So the 2018 fires were, of course, absolutely devastating. And one of the biggest things that came out of the fire reports there was the communication between the fire agencies, so your CFAs, your country fire authorities, and other people working in fire mitigation. Do you think this has improved in all the years since those devastating fires?
So there's a number of different axes to this. So there's a lot of political interests in place in the different organisations in Australia. There's a lot of goodwill to improve communication across boundaries. it's still hard because the organisations are separately funded, and when you fund an organisation, it naturally silos a bit. So the interaction between organisations is never great. It often depends on individuals ringing up individuals, and even with the best will in the world, it's not easy to do that in emergency situations. I think there's multiple things that can still be done. I think there are issues that come from the fundamental nature of our federation, where funding for these agencies is state-based and crossing state borders is hard. And so I don't know how to solve those problems, but I know that there are people in politics and in organisational psychology and all of these fields that can work on it. What I do see is an incredibly important need for Australia to invest in federal standards for information. And that's a critical thing for this community. We need to, for example, have standards for the communication systems that are then deployed in the next 20 years for fire services, so that different fire services can switch on the radio systems and the information systems from another system, so that the interfaces are quick. So these are critical questions, and one of the things that we want to do in the centre is engage in building standards, especially around camera images and data and comms and activities of drones, all of these things.
Thank you very much for your answer. I'll leave you there now, but if anyone's got any other questions for Rob, please just type them in, and we can, if we've got time at the end, we can most certainly address them, or he can just type away while Dario is doing his presentation. So Dario, welcome. You're a network member of Robotics Australia Group, so a double welcome to you. Rob, not that I don't love you, but Dario, would you like to introduce yourself and tell us a little bit about the technology that you're working on?
Yeah, absolutely. So we fit in the picture that Rob just painted so well. Carbonix is about aerial data capture. So I'll just pull up my presentation, share the screen. Yeah, so it's really about that eye in the sky capability. It's saying let's start with you know, what the vision is and how we're implementing it. Being able to have aerial visibility over assets really empowers decision making. So being able to remove yourself from the ground, go up, look down, and really get good, accurate data over large areas is really what makes a difference. And in this case, particularly things like fuel load monitoring, we're dealing with large scales. And so something like a crewed aircraft can cover those areas, but at great expense and with you know, implications around fuel burn and noise impact on the ground and cost and potential safety. So using a drone is an ideal solution to cover those areas, to really get that data frequently with high accuracy, but it's down to how long can you fly to really cover sufficient area to make it economical. So really our effort has gone into making these aircraft able to cover that ground. If you can get to a range where you can cover not tens of kilometers, but hundreds of kilometers in a given flight, then it becomes economical and it becomes viable. And that basically has two components. There's the ability to carry weight, because a high resolution sophisticated sensor tends to be a larger piece of equipment. So if you can fit more powerful optics or multiple payloads working together, you can really paint a picture that, say, for example, both images and 3D models scans. And being able to carry that for a long time requires an aircraft that is lightweight, efficient, has sufficient fuel load. And really our R&D initially has been around building that platform, around building an aircraft that has the ability to cover sufficient area to make it viable to do this economically. Now, having created that platform, then the next step is, how do you implement it? How do you make it real? How do you get users to really understand the potential, the limitations, the regulations, the various things that need to be put in place around it? So that sort of paints the picture at a high level. We want to be able to provide that data capture platform to be able to say, here's an aircraft that can carry a worthwhile payload that's all integrated, that can get you high resolution data over large distances, and here's a way to implement it to both train people to use it, to get to comply with regulations, to be able to fly not just in remote areas, but eventually in more coordinated fashion. And so that's really the work that Carbonix has been doing. In the bushfire area specifically, so most of our work is in infrastructure. So we do scans of power lines, open cut mines, things like coastal erosion surveys, national parks, and that uses different payloads. But really the power line stuff is quite relevant, because part of that, the usefulness of that data is being able to see whether there's vegetation encroachment onto power lines. So being able to, again, really on a day-to-day basis at high resolution over large areas, create a model of that infrastructure and really point out where are the areas where we need to intervene, where do we have to go and prune a tree, where do we have to do maintenance on the lines. And again, that's all enabled by the platform that we've created and the relationships that we have with customers that have given us feedback about what they want to see and how they want to operate. So moving to specifically the bushfire work that we've been doing with the ANU, and also collaborating with Andrew Tridgell and the RG pilot program, which makes it all a very Australian capability. As Rob has already laid out, the prevention, the fuel load mapping is really a surveying exercise. And we fit in an ecosystem between, say, satellites and other ground-based methods and, say, shorter range drones. But we're able to give that centimeter resolution over large areas using a LiDAR, a camera, so that we can both have 2D, 3D, and texturized images. That initial fuel load monitoring is again a scanning exercise that is basically generating good data that can then be fed into models to look at what is the fuel load, what is the moisture content, how is a fire likely to spread and behave. And we again partner with people who specialize in that. Then the early detection piece, the storm chasing, is really the interesting work that the ANU has been doing, where we can go out at short notice, at night, in inclement weather, when you wouldn't necessarily want to deploy a helicopter or a manned aircraft, and go and cover those areas and look at where a hotspot might be. Using a thermal camera, that becomes very obvious because you see the contrast straight away between the terrain and a smoldering tree trunk. And again, being able to cover the area is really the key. So moving on to the aircraft itself and what enables us to do it. Again, geeking out a little bit on the physics. If you want to create a flying machine to carry a camera, there are basically three options. There's a lighter than air aircraft like a balloon, there's a multi-rotor, and there's a fixed-wing aircraft. A multi-rotor being, a quadcopter, what people normally think of as a drone, the sort of the commoditized version. It flies by one of the definitions is beating the air into submission. You've got four rotors that are working away, pushing air down to keep a multi-rotor flying. This allows them to take off vertically, to hover, to fly, left, right, back, forward, but it's just fundamentally inefficient. You end up, you're using so much energy to stay in the air that your range is fundamentally limited. So to cover long distances, fixed-wing aircraft is really the efficient way to do it, because the wings are moving through the air, they're generating the lift, and the energy on board goes into creating thrust to overcome drag. The drawback of a fixed-wing aircraft is that it has to be accelerated up to flying speed and then decelerated back on landing. And to do that, you ordinarily need a runway or a catapult system and some sort of arrestor, which is bulky and inconvenient. So we've combined a vertical takeoff and landing system with a horizontal flight fixed wing aircraft. And again, there's a lot of work that goes into that in terms of the design of the aircraft, the materials, and the integration of the avionics, the autopilot, plus a lot of testing in terms of making sure that it behaves as expected over time. So really our specialty and the work that Carbonix has been doing has been in creating this platform that is capable of covering the area of going, staying in the air long enough to cover the areas and the distances required to make this economical, and to do that day in and day out with a reliable, well-engineered platform. Just looking at the slide I have up, basically it's a fixed wing aircraft with a VTOL system, vertical takeoff and landing. We have an electric version and a petrol hybrid version. The petrol hybrid version basically uses a petrol motor for horizontal flight, and also charges batteries in flight to provide power to the avionics and the payload. And again, that's really what gives it its range. It's designed to pack into a box or a trailer, be taken out to site, assembled very quickly, launched vertically. So again, you don't need a road or a runway or any launching equipment. And then once it's in the air, it transitions to horizontal flight. The pusher motor basically keeps it in the air, and it sips a tiny amount of fuel, and that's what gives it the range. So down to flying characteristics, when you're surveying or scanning, it's a very different proposition to, say, a transport drone where you're trying to get from A to B as quickly as possible. We are designed to fly slowly. That allows the payload to get a good image of what's going on the ground. And that has to be able to work regardless of wind and weather conditions. So again, that's down to the design of the aircraft, the avionics, the way we've tested and tuned it, and all of the work that we've done with our customers to actually optimize how we operate this thing, where we position ourselves relative to the target. And basically, it's all about creating this useful data that can then be fed into models and used on the ground to make decisions. So this is just a bit of a comparison. Again, you've got multi-rotors, you've got crewed aircraft, so helicopters and small fixed wings, and then you've got a Rotano drone that really has this flying capability that exceeds the range of a lot of certainly crewed helicopters, and is able to do that at a lower fuel burn, a lower cost, and in conditions when you wouldn't necessarily put a human in the air. Yeah, so this final slide is really just about, and again, we can go into this during the questions, but to get the capability that we have, all these different complex elements have to come together. So you need an airframe, you need the materials capability to design and build a shape that's lightweight enough, yet strong enough, shaped optimally, aerodynamically. It needs to have the command and control systems on board, so the avionics, to know where it is, know what it needs to do to maintain flight, react to changes in the environment, to faults, diagnose issues with itself and make decisions. And then you need, obviously, a propulsion system and power distribution, ways to keep the whole thing powered up and all the different bits working together. There's a challenge there in terms of radio links. And so integrating all of that is really what Carbonix does best. Just going through some of the images in this slide that are just representative. So on the left, you have the new aircraft with the Optus livery that they've been using to fly different payloads and to validate the different missions that Rob was just talking about. In-house, we have things like jigs to test the strength of the wings. So you can see on the top right there, we've got what we call a whiffle tree, and we're hanging bottles of water off a wing to make sure it behaves and flexes and has the strength that we require. We have test stands where we'll put a motor on there and run it for prolonged periods to understand how it behaves over time. And then we'll do flights like, for example, that lower image. We've got tufts on the wing to look at how the air is actually behaving over the wing as we're flying. And then finally, lower right, we're on a barge in the middle of the harbour testing radio range. So all those elements need to come together really to create this capability to generate the information that's needed to make the decisions in the systems that Rob is talking about. Really being able to kind of emphasize enough the importance of getting that data. And that is the conclusion.
Dario, thanks very much. I've already got a couple of questions. So in terms of, since Carbonix has started, how have you seen CASA, which is the Civil Aviation Safety Authority, how have things progressed in terms of legislation for drone flying and doing this sort of work? Because that, of course, impacts heavily for you.
Absolutely, yeah, leaps and bounds. When we started, it was all very new. Even as simple as being able to categorize, again, multi-rotors, fixed wing, vertical takeoff and landing fixed wings. Those categories were created relatively recently. And really it's about understanding the technology and the risks and mitigating them. And CASA has actually been among the world leaders in terms of having an open mind and really assessing what companies like us or operators like us put in front of them, and being flexible in terms of assessing the risk and providing exemptions and instruments and ways to achieve these missions in a controlled way, where you're balancing the ability to go out and actually do what we want to do and provide the value that we provide against a known way to understand and mitigate risk. So certainly compared to other countries where it's been a little bit slower, here they basically take the view that as long as you've thought through what you're doing and you can prove that you're managing the risks and you're doing it in a reasonable way, you will get to at least a position where you can go into a trial or do progress to a point where you are able to do the mission. So that the big sort of leap has been what we call beyond visual line of sight. So basically they set out early on and said, if you are flying a drone, you need to be able to see it. So the standard conditions are the pilot on the ground is looking up at the drone as it's flying. That really limits the aircraft to something like a kilometer and a half radius around the operator, which again for a multi-rotor is about as far as you can go. In our case, if you're wanting to exploit the range of the aircraft, you really need to be able to fly beyond that visual line of sight. And over the last couple of years, there's been a process put in place to allow, to effectively grant permission to fly beyond visual line of sight over specific areas that you, as an operator, will nominate up front. That's now becoming more and more routine, and in our case, we have several of those approvals already in place that we've flown. Again, there's always a question of the industry has grown faster than probably anyone expected, and that the regulator could sort of set themselves up to deal with. And so they do tend to be not so much under-resourced, but there are waiting times involved, and there's still room for improvement in that area. But the approach that they're taken is very pragmatic, and it's really allowed us to push the limit and to prove our capabilities in the real world.
I've actually heard from quite a few people in the drone industry, because of course there are probably more than about 2,000 companies dealing with drones in Australia, because they're all registered with CASA, so we know this information, that they are, as an organization, very willing to try and assist and get things going as quickly as possible. Again, it's a bit of a catch-up situation because technology is developing and moving so quickly.
That's exactly right, and you sort of can't be prescriptive about it. You can't look at what's around today and say, well, let's set a bunch of boundaries around it, because by the time you've done that, it's changed. And actually, there are initiatives like Air Services Australia, for example, is already looking at what they call advanced air mobility and eventually air taxis, and how is that going to fit into the coordination of airspace over populous areas. And in that case, that tech isn't actually viable yet, but there's obviously companies working on it where it will become a thing. And so that approach of CASA saying to operators, tell us what you want to do, show us that you've assessed the risks, and tell us how you've mitigated them, really has allowed us to approach that sort of on a case by case, but by doing that, we're building up a database or a history of having done these operations and having shown that they're safe. And that allows us to then progress further and further. Now, over time, in order to address the backlog and the delays, I think there are instruments available which are in the works, like being able to delegate to an operator the ability to make those approvals themselves based on a robust process. So at the moment, as an operator, you're saying, here are my processes, CASA's approved them, I want to do this mission over here, CASA has to go over the plan and approve it. I think eventually we'll be closer to how airlines operate, where the processes are audited and they then allow the airline to, or the operator, to do their approvals internally based on these approved systems, and move a little bit faster in terms of adoption. Now, in our case, because we are scanning fixed infrastructure, so power lines in particular, mines, once we have that BVLOS approval over that piece of infrastructure, we can then operate that again and again and again. So it's there is that initial work that you have to do to get it, but then once you have it, it's sort of business as usual.
And you mentioned the drones. Are you actually doing the production in-house? You're doing it at your warehouse in Sydney?
Yes, so the R&D, the development, the test flying, anything to do with getting the technology ready for rate production happens under one roof. And that's one of the unique things about Carbonix. We have expertise in-house around everything from the carbon fiber that goes into the airframe, the aerodynamic design, the electronics, the payload integration, the operation, and helping customers with basically bringing operations into their business as usual. So permits, safety, things like that. But once we have a system in what we call design freeze, where we've built a few prototypes, we know that it works, it's documented, and we're getting into a state where we now want to basically repeat them, then we use partners. And we have, on the manufacturing side, Quickstep, which is an Australian listed defence company that does carbon fiber composites for defence. They are very keen to get into sort of the uncrewed world, and we've worked with them very closely in terms of taking design frozen, sort of ready for production aircraft and putting it into their world where they can scale production really quickly and effectively, we say, print them out. Similarly with the avionics, we have a company called GPC Electronics here in Sydney. They print up PCBAs, populate them, create our wiring harnesses, etc. And again, they just have that ability to scale without us having to commit to more plant and more people to just do the same thing again and again.
Since Carbonix has started, you've mentioned that the data mining is so important. Has anything jumped out at you that you can talk about in all the years that you've been collecting it?
It's really being able to position the aircraft in the right way to get the data that we need. So that's something that we work with customers with. And that's everything from, you know, the angle of the lighting to how we calibrate the sensors to how we then ingest the data into a post-processing system. It's very collaborative, because as much as you can have a great aircraft that flies really nicely and carries the best payload, how you actually deploy it is down to how we collaborate with customers. So what do they want to see? And we'll do a mission and they're like, well, if you've just been a meter to the left, you might have got a better angle over this, for example. And you do that again and again and again, and you build up a set of procedures and a knowledge base for how to fly the missions to best effect. I mean, as far as things that have jumped out, the initial flights that we did with LiDAR were actually quite eye-opening in terms of you can get multiple returns, you can get very dense point clouds that are very accurate in space, and you can see, you know, layers of vegetation, patterns in the landscape that you might not have otherwise seen. It really drives home how important and how valuable it is to sort of zoom out and have that ability to put a camera in the sky and see things from a bird's eye view. Occasionally with the photography stuff, you might see kangaroos, you might see things that you wouldn't otherwise expect, but really it's that business as usual. It's like covering the area and doing it again and again.
I work with a lot of companies, and there's always this intersection of academia and industry. And Rob, feel free to jump in here. What's been the biggest benefit of your organization working with ANU in terms of just getting ahead quicker than you may have otherwise?
Well, as Rob said, I mean, they're specialized in R&D. So firstly, you have a sort of independent, trustworthy, well-regarded, respected entity that's validating your tech, that's showing that it works. But also we've co-developed a lot. So particularly with the ANU, because they have the ArduPilot program is basically resident in the ANU. So ArduPilot, for those who don't know, which Robotics Australia, probably everyone does know, is effectively an open source autopilot system, and it can be used to control everything from aircraft to underwater vehicles to ground vehicles. And there's really been a co-development where adapting ArduPilot to our system, so to a vertical takeoff and landing fixed wing aircraft where you have very complex energy management to go from horizontal flight to vertical flight, being able to work closely with them where they're flying the aircraft, they have one, they can give us feedback, we can incorporate that feedback into our development work, we can then send them the latest version of the software and they can play with it and vice versa. They can also give us feedback about the practical aspects of having this thing out in the field, what might get knocked around, where the dust might become a problem. So that very hand-in-hand collaboration where they're doing development work on our aircraft and feeding that back into what we're doing. And then beyond our wheelhouse, which is the aircraft and the operation, being able to see how it fits into the ecosystem. So as I said, satellites, ground monitors, neural networks that detect different things, really what's our role in that ecosystem, and the ANU really has a good big picture idea of how that works.
Rob, you're currently on mute, but did you want to jump in and add anything to that?
No, not a lot to add. I mean, I support what Dario says. It's been great working closely with Carbonix, and the capability that we're getting is very adaptive. I should say ArduPilot is an independent open source community. One of the lead developers, Andrew Tridgell, has an adjoint position in my lab. So we are very closely coupled, but it's definitely not an ANU. It's an independent entity. We do a lot of science that goes into ArduPilot. So I do a lot of the estimators and stuff. Yeah, I mean, I guess, yeah, there's not a lot to add. It's a great collaboration, and the capability that we're demonstrating fits into the high level vision that we're trying to create for the bushfire mitigation. So,
congratulations. Yeah. There's a last, Ian's flicked out another question. How do you handle this data acquisition? Is it all real-time visible, or is it post-flight extraction from onboard storage? Rob, I think you started typing an answer there, so you're welcome to put some in, or Dario, either one of you.
I can say what ANU does. I mean, Carbonix obviously caters to multiple clients, so I can only really talk about the ANU experience. And there we're working to a model where we work in both real-time and offline. So the detailed data would be collected online, but we would also be wanting to have a real-time interface that we can evaluate things from a pilot. So we would see there would be a pilot, supervising pilot for a group of drones who would then be able to look at specific data in real time. We transmit through the RFS Silvus radio. It's a networked radio system. We also have a 5G system if that drops out, and we have our local radio systems. They have threefold redundancy in the radio. But in terms of the onboard work, we would actually be looking at, for example, where we believe that there might be an ignition or we have a high risk of ignition, we'll actually circle the ignition and acquire data in a circle around it. And then we're working on algorithms to remove tree cover so that we can actually look through the leaves of the trees and look at the ground that would be done on board in a processor, and you'd only pass the 3D image up. So they're the sort of things that you can do with a company like Carbonix, where you can then plan the data transfers and such like. Yep.
Yeah, absolutely. So just from our point of view, it's mission specific. So on a surveying mission where you're basically scanning terrain or taking photographs, or both concurrently in the case of Otano, you're storing it on board, because basically after a 3, 4, 5 hour mission, you'll land, download it all, and then feed it into a post-processing software. For something like an ISR, intelligent surveillance reconnaissance, where you're flying a video camera, then you'll want to feed that to a ground control station where someone on the ground can look at the screen and see the live feed from the camera. So it really depends what you're trying to do. Ultimately, transferring video over the radio link is feasible. Once we start getting into things like high density point clouds and multiple payload feeds, then really the radio link becomes the limitation. But we generally store surveying data on board, and so surveying data on board and live feed can go to the ground control station in real time. And I guess the next step after that would be some sort of automation where, rather than a human looking at the screen, an algorithm is looking out for anomalies and then flagging them as you go.
If I could add one thing, there's an in-between there where the onboard systems produce data products. So video is not necessarily what you want to look at. So, a compiled 3D image could be transmitted from lots of video, computed on board and transmitted at much lower data rate, and provide the information you need to look at. So there's lots of space for different data products to be developed that are computed on board and transmitted out for real-time surveillance type applications.
Yeah, and again, the enabler there is the ability to carry the weight, because you're carrying compute on board. That's part of the payload. If you have an aircraft that can carry it, then you can do it.
Could I ask you both one last question in terms of bushfire mitigation and management in Australia? If there's one thing that you both think is absolutely critical going forward, what would you say it would be?
Rob, do you want to take it first?
I'll take that one first. I think there's an understanding of the need for new technology. I think it's important for technology companies to recognise the skill set that exists in the fire services, and what they know, and they do very well. So it's important when we come into that environment to recognise the knowledge that's there and work on the new problems that they need to work on. And in that space, the one thing that I think, beyond the technology development, which I think is happening, that needs to happen Australia-wide, is we need to grasp this question of standards and regulations on data products, and that's critically important.
Yeah, couldn't put it better myself. I think certainly standardization is important, that interoperability, and really a clear path to adoption. How do you go from something like the work that we've done, the demonstrations that the ANU has done with live demo days showing that the technology is sort of ready to be used in the field, to an agency that hasn't seen something like that before, getting their head around how it fits with their day-to-day and how it will make their lives better.
Thank you to you both. I'm mindful we 1 minute short of 1 o'clock, and I'd like to say thank you so much to you both for being available to speak to us. This video webinar will be available on our website. To our audience, if they have any questions, I'm assuming it's okay to put your contact details in the slide, Rob and Dario, that's okay? Thank you very much. Okay, it's happening. So, and if you haven't connected with them on LinkedIn, do so immediately and continue the conversation there. Thank you very much for joining us today, and Dario and Rob, thank you for your time. It's much appreciated, and we look forward to your company next month with robotics in construction. So should be an interesting topic. Thank you so much. Cheers.
Fantastic. Thank you.
Thank you.
Thank you.
Yes, thanks.